in WSU Northwest Washington Research and Extension Center. His big title is Pollinators and Pollination Tools in Northwest Highbush Blueberry.
Thanks, Rishi. Okay, so for those of you who just came in, again, I'm Matt Arrington. I work with Dr. Lisa DeVetter at the WSU Small Fruit Program, and today I want this talk. I want to talk about pollination and some of the things that we've been looking at these last couple years to try to overcome some of the chronically low fruit set that sometimes can be experienced. And so to start off with, just a little bit of the justification for these projects. Washington State produces the most blueberries nationwide. In 2016, we produced about 60,000 tons of berries off of approximately 10,000 acres. It's important to know that to remember that our industry, the blueberry industry, is continually growing, and that as it continues to grow and the market becomes more and more competitive, things like fruit set and pollination are increasingly important. And so to start out with, and it looks like the slide is squished a little bit, so we may see some of these words get messed up, but some background information. Like I mentioned before, we've had reports of this chronically low fruit set, particularly in areas like Western Washington, British Columbia, maybe Northwestern Oregon, areas where spring is going to be a little wetter or a little colder. And so that is a cause for concern as far as pollination goes. And part of the reason for that is that blueberry pollination is primarily carried out by honeybees. And I say in here Italian honeybees. I think that it's more difficult to say that and be accurate. Recently, I think that as more subspecies of honeybees become more common in pollination, I think it's more effective to just say honeybees in general. And much of those still are Italian honeybees, but there are also Carniolans and Caucasian bees as well in there. And so in looking at honeybees, one of the primary concerns is that honeybees lack this coevolution with Vaccinium species, with blueberries in particular. And so as we talk about some of the things that honeybees can't do that bumblebees are very effective at doing. Bumblebees are the native pollinator of blueberries, and they're a highly effective pollinator. One of the reasons why honeybees have trouble where bumblebees are successful is that honeybees can't buzz pollinate. That's that flexing of the flight muscles to vibrate the flower and cause that dehiscence of pollen. Also, honeybees have a shorter average tongue length than bumblebees, and this can cause issues in accessing nectar rewards in the flowers, especially with a long tubular-shaped flower like blueberries. And then another important component of this, the troubles of honeybee pollination in blueberry, is that foraging activity can be negatively impacted by weather conditions, particularly looking at air temperatures that are below 65 degrees Fahrenheit. Foraging activity is reduced. Below 55 degrees, it's almost completely stopped. Wind speeds that are over 12 miles per hour, honeybees tend to go back home to the hive. And then also conditions with precipitation. And we mentioned in that last talk that we looked at honeybee visitation during the hours of 10 a.m. and 4 p.m. And that's typically because those hours are the time when, especially early in the season, when pollination is going on, when temperatures are warm enough. So in contrast to that, bumblebees are a native pollinator for Vaccinium species. There are many subspecies or species of bumblebee. In our area, one that we looked at was Bombus vosnesenski. Bumblebees forage under a lot broader set of conditions than honeybees, particularly in light to moderate rain. In our yard at home, we've seen bumblebees out pollinating in force the rhododendron plants when there's snow on the plants. They also pollinate early in the morning, late in the evening. They are able to buzz pollinate. They're not as reliant on having kind of a landing pad as honeybees can be, and so they don't have the same trouble kind of fumbling around with the flower in order to perform that pollination. So a lot of areas where we struggle with getting effective pollination with commercial honeybees, where bumblebees are much more effective pollinator of blueberry. And so in looking at some of the parts of the plant that may further complicate this issue. So as you can see here in this picture, I don't know if oh, there we go. Okay, so you can see this cutaway of the flower, that our anthers are down here inside the flower. The opening is relatively small, especially compared to other honeybee pollinated crops where they may have much more open flowers. It can be difficult for honeybees to kind of enter the flower, to get their head and their shoulders inside, making contact with anthers, and able to be in a position to reach those nectar reserves. In addition to that, blueberries have a relatively short pollination period, ranging from 7 to 12 days under ideal conditions, and then being reduced to as few as 5 days under less favorable conditions. And so that can be a real problem if we have poor weather and our pollination period is reduced down to 5 or 6 days, and during those 5 or 6 days, 3 or 4 of them are spent with heavy rain and low temperatures. That can really hurt our chances of getting effective pollination during that pollination window. And so just kind of following up on that, there are a couple of factors that were primary concerns in looking at this project. So first, that floral morphology, looking at the entry of the bee to the flower, how accessible is the pollen? Again, that lack of coevolution, the buzz pollination, the size, the tongue length, foraging conditions with the weather. And then another component was poor hive health, and talking about some of the issues that surround honeybee genetics, nutrition, some of the pathogens and the mites. Beekeeping is very difficult, and there are a lot of stresses on honeybees. And so these are all components to why pollination is sometimes ineffective. And then finally, just before we jump into kind of what we looked at, the recommended honeybee stocking density has been 4 hives per acre for Highbush blueberry. And that's kind of the crux of this project, was to look at if that's still effective, if that's effective in our area, or if there are other recommendations we can make that can increase pollination efficiency. And so we looked at 2 main components of this project, and I'm going to talk a lot more about the first one. So first, we compared the current honeybee stocking density, which again is that 4 hives per acre, to an increased density of 8 hives per acre. In addition to that, we measured the potential benefits of supplementing bumblebee colonies in addition to our commercial pollinators. And again, this is the component I won't talk a lot about. Part of the issues that we had was in placing bumblebees that were the source that we used in the first year was capturing queens in the wild and then rearing them indoors, and then providing a colony of sufficient strength to be placed in the field. And the timing for that was very difficult as far as getting them out early enough for blueberry bloom. And one of the issues that we had was that we changed the cultivar from Duke to Draper to try and get a little bit later of a flowering and be able to put the bumblebees out. We still had issues with that, and the first year we didn't get bumblebees into the field until about 80 to 100% full bloom. In the second year, that source became unavailable, and we weren't able to place them at all. And so I won't talk much more about the bumblebee component of the project, other than just to say that they're highly effective pollinators. But to be able to continue that kind of research, we really would need to see a more secure source for those commercial bumblebees. So, in moving on, both the Hive Density and that bumblebee project were set up in the same way. Both had 6 commercial sites in Western Washington, both in 2016 and 2017. And in the Hive Density project, again, we had 8 hives per acre as our treatment of the high density, and then we had 4 hives per acre as the control. And in the bumblebee project, we had the control 4 hives per acre, and then the treatment was 4 hives per acre plus 3 colonies of bumblebees per site. These were all in mature field sites. The high density was done in Duke and the bumblebee in Draper. And then these sites were separated by approximately 5 miles or more from each other. So a little bit of review from that last presentation, and I'll just kind of move through it really quickly. We looked at honeybee visitation, bumblebee visitation in the same way. So we marked off 30 plants within the field, and we watched these plants for 3 one-minute intervals, counting the number of pollination visits that were happening, and this kind of made up our honeybee visitation. They'll talk more about later. We were excluding, again, nectar robbing visits or visits where the bee was around the flower but not pollinating it. And then in addition to that, we evaluated colony strength, hive strength, by counting the number of bees that were leaving a hive or returning to a hive in 5 one-minute intervals before and after doing our other visitation observations. In addition to the bee visitation and the hive strength, we looked at fruit set, estimated yield, berry size, berry firmness, and then seed number per berry. And what we found was that we had uniform hive strength across sites. All of these sites were utilizing bees that were from the same beekeeper, and so this was not outside of what we expected. We also saw that visitation rates were significantly increased. And so you can see in this graph here, both 2016 and 2017, significantly higher honeybee visitation that in the high hive density than in the low hive density. And then it's also important to note that even in the high hive density sites, we didn't see visitation rates that were high enough to cross the threshold of the recommended bee visits per bush per minute. So that recommended rate is approximately 4 to 6 bees per bush per minute in the warmest part of the day. And in the warmest part of the day, we were really only hitting between 2 and 3 bees per bush per minute, even at our high hive density. We didn't see a significant increase in fruit set between treatments. So even though we saw increased visitation, and as I'll talk about in a minute, we saw increased yield, we didn't see an increase in fruit set. And part of the reason for that, we think, was 2016, 2017 were both fairly favorable pollination years for Duke as far as weather conditions went. Fruit set was between 90 and 97%, and so relatively high. And so the increases that we saw in estimated yield were likely due more to increases in the visitation, the seed number, and the berry size, which we found to be correlated. And so we saw increases, again, in berry weight, average seed number, and in yield for high hive density treatments. And then before I move on to some of the take-home conclusions, what we saw as far as economic benefits that we wanted to share. So these are more or less averages from the treatments that we maintained. In our survey of growers that we were using, it appeared that $80 per hive was a good average cost of hives for 2016, 2017. And then we found that the increased hive density of 10 hives per acre, or I'm sorry, 8 hives per acre, resulted in a net increase of approximately $360 per acre. So that's after accounting for those increased pollination costs. And this, in a year where weather was fairly good, may just be providing kind of a safety net for in case weather conditions are bad during pollination. But it's good to know that that elevated honeybee stocking density was still economically effective even in a year when the fruit set was relatively high. And then finally, just some concluding points. Increased honeybee hive stocking densities increase the seed number, the berry weight, and the yield. Bees per bush, the recommendation wasn't realized even in the high hive stocking density. And so I think that that means that we should be looking more carefully at whether or not that recommendation is something that fits for our region. Maybe we can economically increase the stocking density more and see further benefit. This is something that would need to be looked at further in the future to evaluate where this fits in with that recommendation. And then further research and commercial investigation would definitely be beneficial in looking at Bombus species, specifically Bombus vosnesensky in our region. But again, a reliable source would be necessary for that research to move on. And then just finally, as a point of interest, we saw that the proximity of hives to specific plants was correlated with increased fruit set, berry size, and yield. This wasn't something we set up the experiment to look at. It was just an observation that we made during the course of this project, and it's something that's interesting to think about. The potential that there is for spreading our hives around more may provide some kind of improvement in fruit set above placing them kind of in a communal spot, which in our experience has been traditional. Something that would need to be looked at further to be able to kind of give a definitive answer to that, but something that was interesting nonetheless. And then finally, just a big thank you to Dr. DeVetter and the Small Fruit Lab grower cooperators who worked with us these last few years, Belleville Bees and Bee-Man Exterminators, as well as the funding sources, the Washington Blueberry Commission and the Northwest Agriculture Research Foundation. We're grateful for their support. So with that, thank you very much, and I'd be happy to take any questions if there's time left.
It's on. We're going to change up the mic. Question mic so we don't have so much wandering around. If you have a question, I'm going to put the red mic up here on the stand. So just come on over and ask Matt any questions you have.
Oh, yeah, before I forget also, we have a pollination handout that's on the back table, I think. So if you would like to have more information to take with you, those are back there. Feel free to grab one of those.
Matt?
Yep.
Could you go back to the figure with the berry weight and seed? You said that was Duke and Draper?
This is Duke only.
Just Duke.
Yes,
Okay.
yeah. The Draper was the Bumblebee project, which we didn't show data for.
Okay.
Yeah.
Thank you.
Okay. Well, I'll be around if you have something else that you think of. I'd be happy to answer questions. So, thank you.
Thank you, Matt.
If anyone's looking for pesticide credit sheets, I'm about to put them out on the tables back here. You can find Oregon and BC under the signs and Washington under the Washington sign.